First 10 multiple choice. 2019 past paper, this is the first 10 multiple choice. Okay, hydrogen will form a non-polar covalent bond with an element that has an electronegativity value of, this is such a gift. Okay, so I've pulled over the electronegativities page, well, not even all of it, just the top little bit. It tells you that hydrogen has an electronegativity of 2.2, and therefore if we're looking for a non-polar covalent bond, it will need something else with 2.2, so C. Okay, question 2, which of the following is a polar molecule? And you're given various different ones. Now, I genuinely expect that you know which one it is almost straight away, but just to be clear, okay, if you have carbon with 4 of the same substituent groups attached to it, so chlorines or hydrogens, which is also there. I realise for some reason I've got drastically different sized chlorines, but that doesn't matter. Okay, so these two are definitely out. One, they're showing exactly the same thing, and two, it is completely symmetrical and therefore non-polar, right? Which leaves you with your ammonia and your carbon dioxide. Now, carbon dioxide, I expect you to recognise is a linear molecule, which again means that it is non-polar. Ammonia, you should recognise even from Nat 5, it is your trigonal pyramidal example. What you've got here is definitely a top and a bottom, and so therefore it is polar. Okay, which of the following is most likely to act as a reducing agent? And this is actually, I think, quite a tricky question because it's not a straight lift from the data book. I've obviously pulled over data book stuff, but you also need to know some other stuff as well. So what you need to first of all remember, okay, if it's a reducing agent, okay, that means it is oxidized. So I need something that is going to be oxidized. Okay, now, so the reason I pulled over the data book, and I'm going to just change that to a slightly different highlighter. Okay, these two are in the data book, in the reduction series. Okay, here we go. Here's MnO4, and here's your dichromate. Okay, both of those are reduced. So if they're reduced, they cannot be being oxidized. So I can get rid of these because of that, which leaves me with carbon monoxide and hydrogen peroxide. Now, you actually have this as a content statement that hydrogen peroxide can be used as an oxidizing agent. Okay, so if it's being used as an oxidizing agent, it is being reduced. So it's not hydrogen peroxide, which leaves us with our carbon monoxide. Now, that's what's happening basically when it's being oxidized. We should know that that's a further oxidation, and you may remember it. You may remember it just straight as Ku from the blast furnace in Nat 5. Okay, it's not the nicest question. Okay, find my mouse again. There we go. Okay, following reactions take place when nitric acid is added to zinc, and we've got a little reaction set. How many moles of zinc are oxidized by 1 mole of nitrate ions? So what we're looking for is to balance off this half equation set and therefore work out what's going on. So this is 3 on this side and 2 on the other side. So I'm going to multiply this whole thing by 2. I don't actually need to do all of these, I'm just putting them all in so it's clear. Okay, and then I need to multiply the zinc one by 3 so that I end up with, most importantly, 6 electrons going in and 6 electrons coming out. Okay, which means that when I'm looking at the zinc to nitrate, I have NO3, I've got 2 of them, and I have 3 zincs. Okay, that's my ratio. So then we're asked for, if you had 1, what would you have? So then it's just a straight mole ratio, and there we go. Okay, which of the following compounds is a tertiary alcohol? To be honest, I think you're just going to do a bit of work for this one. I think it's easier if you just draw them out. Okay, so we're looking for a tertiary alcohol. Tertiary alcohol must have the hydroxide attached to the carbon, must then have that carbon attached to 3 other carbons. Okay, so you can know what's going on here. You might be able to look at the names and see. But I just think it's easier to draw it out, to be honest. Okay, so first one is 2,2-dimethyl propan 1-ol. So we've got 1, 2, 3 with an OH here, and I've got groups, carbon groups coming off here. That's not tertiary. Okay, I've then got 2-methyl-butan-2-ol, 1, 2, 3, 4. Here's my OH group and a methyl group coming off this one. There we go, 1, 2, 3. There's my tertiary. Okay, pentan-3-ol, just to be clear, 1, 2, 3, 4, 5, and 3-ol. So I've got my OH there, but I've only got 2 carbons on either side, so that's not okay. And 3-methyl-butan-2-ol, 1, 2, 3, 4. Here's my OH group, and there is my methyl group. Okay, so I've still only got 2 carbons attached to either side. So the reason it's B. Question 6. Molecule X has the following structure. Which of the following could be produced by partial hydrolysis of X? Okay, so what we're looking at here is a short, very short section of a peptide joining. Okay, so we've got amide links here and here, but it's actually amino acids that we've used, so we could call them peptide bonds if you want to go the biology route. Okay, so I've got C double bond O bond N bond H, and I've got C double bond O bond N bond H as 2 joins. It says partial hydrolysis, so that means either snapping this one or snapping this one. Okay, so I've just got to look to see what I would get. So if I snapped, say here, okay, I would end up with all of this and back to being carboxylic acid here. And I would end up with a nitrogen NH2 on this side and all of that there. If I snapped at the other point, I would end up with a longer one on this side, ending up with a hydroxyl group, and a shorter one on this side, ending up with the NH2. Okay, so then I'm just going to go and find them. And if I look, this one sits very nicely there. Okay, the rest of them just don't fit. You can sit and work your way through them. If I can see why this one's not here, oh, it's because I'm missing that one, this bit up here. This one has a CH3 in the wrong place, and same with the following. Okay, so just work it through, find the right one. At least it's A. Okay, a compound with a molecular formula C6H12O2 could be. Right, we're just asking you to figure stuff out from this one. So let's see for a start, if it's C6, just doing a quick count, that's a hex, that's a methyl with a pent, so that's a 1 and a 5, that's a pent with an eth, so that's a 5, 6, 7. So let me just get rid of that straight away. Okay, and we've got a 6 here. Okay, so I've got 3 of them that are in the running. And then I'm going to look, and it's an O2, which means I need to have something with 2 oxygens, obviously. This is a 2-one, so that's just a C double bond O. So that's only got 1 oxygen, getting rid of that. And this one has an OH group. That's only 1, get rid of that. Hexanoic acid, however, will have this. I like that. Just to be absolutely clear, I would be very happy drawing them all out just to check. Okay, so I could draw pentyl ethanoate. 1, 2, 3, 4, 5. Oh no, sorry, ethanoate. So put that way. But as I say, we know straight off that's a problem because I have the wrong number of carbons. Okay, hexan 2-on, 1, 2, 3, 4, 5, 6. And off number 2, wrong number of oxygens, and pentan 2-ol, 1, 2, 3, 4, 5, OH off here, methyl off here, and as I say, wrong number of oxygens. But don't let that stop you counting off the hydrogens if you need to. And hexanoic acid, just go back from this one, 1, 2, 3, 4, 5, 6, and just to be absolutely clear, 2 oxygens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. Checked 50 different ways, always good when you're doing a paper. Okay, Oxidation question. Compound X reacted with hot copper 2 oxide. Resulting product did not give a colour change when heating with Fellings. Okay, so what you're looking at here is your alcohols. So if you have a primary alcohol, you can oxidise that to make an alkanal, or rather an aldehyde, since I just said primary as a standard thing. So, and then we can oxidise that again and we will get a carboxylic acid. Okay, if we had a secondary, then we can oxidise that to a ketone and then we can't oxidise that any further. Okay, tertiaries just refuse to go. So what you're told is that you had X and you were able to oxidise it. Let's say it made something called Y. Okay, and then when you tried to oxidise Y, nothing happened. Okay, so we're looking for what X could be. So there are actually two options, and this is something you have to be really careful about, because nothing says you have to start at the very beginning. Okay, so I've either got a secondary alcohol, because X was able to be oxidised and then wasn't. So what I would have made there at Y was a ketone and then I'm blocked. Okay, or I could have started at an aldehyde, because if I start an aldehyde, I can go as far as the carboxylic acid, but then I can't go any further from there. Okay, so Y would have been the carboxylic acid and X would have been an aldehyde. So I'm looking for either a secondary alcohol or an aldehyde. Okay, right, and so that's all you're looking for. So let's get rid of pentan 3-one because that's a ketone. Let's get rid of pentanoic acid because that's a carboxylic acid. I'm left with pentan 1-ol and pentan 2-ol. 1, 2, 3, 4, 5. Okay, if it's on the end here, it's a primary. If it's at number 2, it's a secondary. I need the secondary. There we go. Question 9. Structure of pivotic acid is shown. Which of the following is the correct systematic name? I have no idea if I said its name correctly. Anyway, it doesn't matter. Okay, I'm looking for longest chain. Longest chain with the functional group. Didn't actually even really need to go around that corner. Could have gone straight across, but it doesn't really make any odds. I'm going to number this 1, 2, 3. Okay, because I'm going to go with my functional group being the first one that I number. And then I'm going to look for my extra groups. There we go. Okay, so naming this off, our longest chain was a 3, so that's prop. Oh, propanoic. Yeah, it's right, okay. Just looked strange there. Propanoic acid, okay. And then I've got 2 groups coming off number 2. They're both methyls, so I've got 2,2 dimethyl propanoic acid. Oh, sorry. Don't need a dash there, need a dash there. And there we go. Okay, right. The table shows 4 compounds that contribute to the aroma of spices. Which compound is not derived from a terpene? Okay, so if I am not derived from a terpene, what that really means is that I am not derived from isoprene units. Okay, isoprene you just need to know is 2-methyl buta 1,3-diene. Okay, now what that really means is that the methyl is a 1-carbon, buta is a 4-carbon. So if I'm looking for these, I'm looking for multiples of 5-carbon. There's a multiple, there's a multiple, there's a multiple. That's not, there's your right answer. And that has to be the easiest way to run those questions. And that's us done that section.